Okay, students, we're going to talk about exponential growth and decay. We see exponential growth and decay functions. F of x, that's function notation, and they're letting you know the fx is the same as the y right here. Where a is the initial value, so that whatever's here is always the initial value. That means when x is 0. T is time in years, not months, years, and k is a constant of representing a constant growth. Um, uh, and y equals a to the negative kt would be, again, a is always the initial value, e stands for the e, t is in years, and k is representing continuous decay. The negative obviously is showing the decay part, and so k would be positive still, but so you have the negative there. It's showing decay. All right, so let's look at what we do with this. In 2000, the world population was estimated to be 6.124 billion people. In 2005, it's 6.515 billion. Determine the value of k, the world's relative rate of growth. Well, initial value, right here, goes right there, e. In 2005, so 5 years later, in 5 years later, so we have t is 5 years. That y value now is the 6.515, and we're solving for k. So we have our variable that we're trying to solve for up in the exponent, so we have to use, in this case, natural log, because e that goes along with it is natural log, so because the natural log of e is 1, so it cancels out. So again, how do we solve all equations? Reverse PEMDAS, so we divide by 6.124 on both sides. That gives me this. Now I take the natural log of both sides. And then I can pull the 5k out front. Remember, it becomes, the natural log of e is 1, so that cancels out. So I got 5k equals this right here. And last step, divide by 5. Now don't forget, when you put this in, this should be in parentheses when you put that in your calculator. Okay, just like that. And then lastly, after doing that, last step is divide by 5. And you get this right here, 0.01238. So that's decimal. The percent will be to move it 2 places to the right, 1, 2, so 1.238%. And then you went ahead and rounded to the 10th spot. Okay, so again, this is where we would use logs, in this case, natural log. That goes along with E. Whenever you think E, first thing you should think is ln, natural log. When will the world's population reach 7.5 billion people? So when is the time? So that means we're going to be solving for t. Okay, we knew the initial value. We just calculated what the rate of growth is right there, 0.01238, and we want to know what's going to be 7.5 billion. So now we're solving for t again, but it's in the exponent. So again, we need to do reverse PEMDAS, divide by 6.124, take the natural log of both sides, pull this out front, okay, and natural log of e is 1, so that's gone. And last step, divide by this number after. I put that in parentheses, divide by this number right there, put in your calculator, and you get 16.3722. Remember, that's in years. So 16.4 years from the initial value. Remember, the initial value is 2000, so in 2016. Okay. Next page. Logistic growth. Let's see. Well, we're not going to do this one. We'll stop right here. Just on the front page only.